Okay, students, we're going to go over several. I think it's about 35 slides or something like that. Yeah, I think one problem right there, 37. All right, so I'm going to go fairly quick because this should be a review. Okay, notice we have an overlapping triangle here. That means there's a dilation centered at A. Okay, we just got to talk about dilations here. All we know is the scale factor is K. Okay, so we don't know what it is. So number one, it's saying the scale factor is 2. We don't know that, so that's not true. The first two things we should be thinking about with parallelism that are preserved, that are dilations that are preserved, are parallelism and angle measure, if we know the angle measure. Okay, so parallelism, so that means this has to be parallel to this, which is what number 4 is saying. Notice on 2, it's saying AD is perpendicular to DE. We don't know that. It looks like it's 90 degrees, but it's not guaranteed. We can't go by looks. The only thing that's guaranteed is that these are parallel. And whatever this angle is, it equals that angle, and whatever that angle is, it equals this angle because we have parallel lines cut by a transversal. Therefore, corresponding angles are equal. Remember, those are corresponding angles. All right, next. A regular pentagon. Remember, regular means equilateral and equiangular, and this is the common type that we have any rules with. It tells you it's a pentagon there, 5 sides. You should know your numbers. Rotated clockwise around its center. Okay. What's the minimum number of degrees? All I do is do 360 divided by the number of sides or the angles, and that's 5. Yes, that's 72 degrees. 72 degrees. Now remember, that's the minimum. But if it asked you what are all the degrees that will rotate it back onto itself, it's 72 plus another 72, which is 144. 72 times 3 is 216. 72 times 4 would be 288. 72 times 5 is 360. We did not include 360 or 0. Oops. Let's get rid of that there. Need to close that out so I don't keep getting any messages like that. Okay. All right. Now we should be good the rest of the time. All right. So just remember that. What? Come on. I thought I just closed that out. Okay. On to the next. The line y equals 2x over is dilated by a scale factor of 3/2. So we're talking about dilations here, centered at the origin. It's key, centered at the origin. Remember, parallelism is preserved, so it keeps the same parallel slope there, same slope. And all I do is multiply the y-intercept by the scale factor. So 1.5 times 4 is 6. So 2x minus 6 right there. Here we have one scale factor of 2 centered at 3/8. Again, the slope does not change, so it's going to be y equals 3x, which all these are. Now, without graphing it, here's a simple way to do it. I asked myself, oh, that was not at 0.8. Okay, so that's not, so it's at 3/8. Well, the first thing I want to check is if that point is on the line itself. If it's on the line, then it's the exact same. So I plug 3 into the x, I get 3 times 3 is 9 minus 1 is 8. Oh, that's exactly what it says the y is. So 3/8 is on the line itself. So it is that exact same line. All right. Triangle ABC is dilated by a scale factor of 3. Which statement is true of the image? Okay. The image, any corresponding image length is 3 times the pre-image. So that right there is 3 times the pre-image right there. The angle measures are exactly the same, not 3 times. And that one's saying the angle measure is 3 times. And that one's saying 3 times the image is the pre-image. That'd be 9 times. So no. Number 2 is the answer. Remember, it's image or pre-image. Okay. Center dilation, center of the origin here again. Again, we see the overlapping triangles. Okay, we have those there. The ratio of the lengths of BE to CD. So, what the ratio, small to big. I could sit there and calculate that with Pythagorean theorem or distance formula, but any of the other corresponding sides have to have the same ratio if it's a dilation. So it's much easier just to simply count. So we wanted the smaller one, so 1, 2, 3 over the bigger one, 4.5. Okay, or if you didn't like that, which that does reduce down to 2/3, 1.5 is their GCF. Or I could go ahead and just count here, 1, 2, 3, 4 over 6. So that one right there, which is 2/3. The ratio, and you have to pay attention to the order, so it's the smaller over the bigger, 2 to 3. Notice number 2 is 3 to 2 in case you switched it. All right, rectangle below is continuously rotated about side W. That's automatically a cylinder. Okay, just like if I had it over the x-axis, something like that, and they rotate either about the x-axis or y-axis, cylinder. Common one, because you do that in calculus. All right, regular hexagon again. Okay, it says when triangle ABG, this one right here, is reflected over BG, that one right there, well, reflected over, boom, that puts the A to the C, the B stays onto itself, and the G stays onto itself. So now here's my new triangle right there. Okay, then rotated 180 degrees about point G. So that means it goes straight through point G to the other side. So that goes to there, B goes to E. Okay, so B here goes to E, C goes to F. Okay, uh, so here's the triangle point. So FEG, there's FEG. I'm just trying to see if they're trying to mess with you on corresponding order. They don't have any other one that's related to FEG, so that is it. You have the right corresponding order there. All right, determine the type of triangle, scalene, isosceles, or equilateral. Okay, so plot it. 1, 4. 1, 2, 3, 4. 10, 1. Negative 1, 2. Okay. So obviously we have all different lengths. So say it's scalene. We don't have any two that are the same, so it's not isosceles or equilateral. Okay. Don't forget, if you couldn't tell, um, the longest side, which would be this length, is be considered the C. Okay, and so if C squared ends up being greater than the other two sides, the A squared plus the B squared, then it's obtuse, which is what this is going to end up being. Okay, and if C squared is less than it, then it'd be acute. But that we can just look at. Okay, and see. All right, 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. 6, 8. 5, 6. 1, 2, 3, 4. And 2, 8. Okay, well here we should be able to tell it's at least isosceles right now. Okay, because from this point right here I go up 4, left 2, and up 4, right 2. So it's the same slope, same exact counting points to get to other points. So those just are same. I could also use Pythagorean theorem, draw a right triangle. And I have 1, 2, 3, 4, and 2, and this is 4 and 2. So when I do Pythagorean theorem, I get these to be the exact same length, which would be the square root of 20. 16 plus 4 is the square root of 20, versus this length is 1, 2, 3, 4. 4 exactly. So 4 is not equal to square root of 20, so therefore it's only isosceles for this one. Okay, second one is isosceles. Determine the most precise name of the quadrilateral now. So 4, 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 8, 7, 9, 8, 7, and 3, 2. 1, 2, 3, 1, 2. Okay. So again, if I was to connect these, oh, looks like I missed one. 1, 2, 3, 4. I missed one. 7, 3. So 4, 6 right here is, oops, forgot it. A. B is 8, 7. C is 7, 3. So 9, 8, 7, 1, 2, 3. And D is 3, 2. Okay, now it looks like that could be a parallelogram, and it could also be a rhombus, because remember rhombus is a particular type of parallelogram. So as a parallelogram, to prove some's parallelogram, I check the opposite sides and see if they are parallel. So notice, remember, slope is changing y over changing x. You should be able to quickly do this. From A to B, I went up 1, right 1, 2, 3, 4. So that slope is 1/4. Here, up 1, 1, 2, 3, 4, 1/4. So those are parallel. Here I'm going down 4, left 1. And here I'm going down 4, left 1. So those are parallel. So now we know it's a parallelogram for sure, but now what kind of parallel? Can we go more specific? Rhombus, rectangular, square. Well, we know it's not a rectangular square because those are not at 90-degree angles. So the only question is whether it's a rhombus or not. Remember, rhombus means all, of course, all sides are congruent. Parallelogram with all 4 sides congruent. Well, that's going to be the case because each one of these is 1 to 4 on their sides when I draw these triangles to find their hypotenuses. It's always 4 and a 1, 4 and a 1, 4 and a 1. So they are all congruent, which is what they look like, and so therefore this is a rhombus. You need to know the definitions on your quadrilateral hierarchy. Okay. Oops. All right. Graph IJ, negative 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. J, 1, 3. Right there. IJ. Then graph its dilation with a scale factor of 2. So when it says graph its dilation with a scale factor of 2, that means from the origin. Okay, automatically. It doesn't tell me from another point, so it's automatically from the origin. You need to know that. Anytime it's from the origin, all I have to do is multiply the scale factor by 2, so that becomes negative 8. 8, this becomes 2, 6. Okay, so then I'll go ahead and plot that because it says graph it. And I'm just going to say it. So 2, 6, 2, 3, 4, 5, 6, and negative 8, 8. Right there. Okay, center at the origin. Okay, now remember, this does look twice as long. And don't forget, I can sit there and go through corresponding points, and then go to the center of dilation, which is 0, 0, the origin. That lets you know you graphed it correctly. Don't forget to check that. All right, triangle DEF is the image of ABC after clockwise rotation of 180 degrees. Remember, rule for 180 degrees, remember, XY just becomes negative X, negative Y. That's the same thing as reflecting, negative X is reflecting over the Y-axis, and negative Y is reflecting over the X-axis. Okay, so those are intersecting lines, and that's why it's a rotation. Remember, the definition of rotation is 2 reflections over intersecting lines versus a translation is 2 reflections over parallel lines. Okay, they put these numbers on here. So it says after clockwise rotation and a dilation. Oh, and a dilation. Okay, so since it's a dilation, therefore it's no longer congruent. Remember, if it's one of the 4 rigid motions, reflection, translation, rotation, and glide reflection, then it stays congruent. Remember, that's the definition of congruence, and you need to remember that for the DCAS. If I can go from the preimage to the image by any combination, called the composition of rigid motions, also called isometries, then it's congruent. Well, we have a dilation, so that means it's not going to be congruent, which is why we see one bigger than the other. Which relationship must always be true? Well, we know that angle measure is preserved in both dilations and all rigid motion. So angle measures, corresponding angle measures are going to be equal. So you're not going to have an angle measure that's, since we don't know their angle measures, we can't even talk about that. Okay. What their actual degrees are. Okay. Measure angle A over, so A matches up with C. Measure angle A over C. So go that over that. A to C goes D to F. It should say D to F. Notice that says F to D, so that's out. But then we have B to E. So B to E, middle to middle, as C is to F. C matches up with F, yes. So there's my angle measures. Okay, so that's going to be true right there. All right, here's our directed line segments. Okay, they give you the endpoints, A and C. B is somewhere along that end segment. Okay, it says from A to B is 3 parts, from B to C is 2 parts. There's a total of 5 parts. Okay, or that means it's split into fifths. Okay, plot of -8, 7, -8, 7, right there. 7, -13, 7, that's -10, 11, 12, 13. I'm just estimating it right down there. Okay, so if I'm going to go from point A, as we often do in our assignments, doesn't matter, you're going to get the same answer. From A, the x coordinate and the y coordinate. X is -8, 7. Now, I could do this whole problem without a graph at all. So I'm going to show you that right now, for those that want to remember this. Okay, you obviously write down your whichever point you're starting from. I'm starting from A, so I write down the x and y coordinates. Now I ask myself, how do I get from -8 to +7 on the x-axis, those are x coordinates? I have to go to the right. That's positive. How do I get from 7 down to -13? I'm having to go down. So that's negative. So I can get my signs just by checking that right there. See, and that's what I was using the drawing before to get that. Well, I don't need it now. I'm just looking at it right there. Now, what fraction am I going from A? A is 3/5 of the way. 3/5 of the way. Okay? And then this is just my total x and y distance. So what's the total x distance? From -8 to +7 is 15. From 7 to -13 is 20. Remember, they're always going to be a positive number. And now I just do my calculations. And there's my answer. 15 divided by 5 is 3 times 3 is 9. 9 minus 8 is 1. 20 divided by 5 is 4 times 3 is 12. 7 minus 12 is -5. So negative or 1 comma -5 is my answer, which is 1. All right, next. We have the same idea again. P and T determine the coordinates of J that divides the segments of the ratio 2 to 1. Okay. So it's division -2, 1 right there, and 4, 7. 1, 2, 3, 4, 7 right there. Let's go ahead and draw that. Okay. Now notice I have a slope of 1 there, which I could also see from this. 7 minus 1 is 6. 4 minus a -2 is 6. That gives me the slope of 1. So it's going through every diagonal here. So how many diagonals am I going through? 1, 2, 3, 4, 5, 6 total diagonals. Okay. Now, remember the total parts here is 3. And if there's 6 there, then that means for each one part it's going to be 2, because I have to take 2 of those to get up to the total of 6. So I can say from P it's 2 parts. So one part is 1, 2. There's one part because it takes 2 of them to be one part. Now I go 2 more, 1, 2, and there's my answer 2 parts away. What is that? 1, 2, comma 1, 2, 3, 4, 5. 2, 5. So there's my answer right there, which then, don't forget, if I go the other direction, it's 1 part from T. There's 1, 2, so there's 1 part. Okay, exactly the same thing, doesn't matter. Okay, so on the DCAS, you can do this. Okay, but now if you want to, if it didn't come out nicely where it all diagonals like that, okay, I could go ahead and do the normal way. We'll go from P, okay, it doesn't matter which one, X, Y, -2, 1. How do I get from -2 to 4? I'm going to the right. How do I get from 1 to 7? I'm going up. Okay, what fraction is it? It's 2/3 of the way. 2/3 of the way. What's the total x distance from -2 to 4 is 6, and from 1 to 7 is 6. Now I just do my calculation. 6 divided by 3 is 2, times 2 is 4, minus 2 is 2. 6 divided by 3 is 2, times 2 is 4, plus 1, I don't know why I have it there, plus 1 is 5. I get 2 comma 5, which we already have down there. Okay, so there's two ways. All right, here we have the same thing from A to P and P to B. So it's 2 parts away from A and 3 parts away from B. Okay. I won't graph it this time. I'll just do it math-wise, and we'll go from, let's just go from B this time. Okay. We've been going from A all the time. Let's go from B this time. X, Y, what's B? 4, 0, 4, 0. I look, how do I get from 4 to -6? I'm going left. How do I get from 0 to -5? I'm going down. Okay. What's the fraction? From B, I'm 3 parts of the way, 3 out of 5, 3/5 of the way from B. What's the total x distance? From -6 to 4 is 10. What's the total y distance? -5 to 0 is 5. There we go. 5 divided by 5 is 1 times 3 is 3. 0 minus 3 is -3. Oops, 10 divided by 5 is 2. 2 times 3 is 6. 4 minus 6 is -2. So my answer is -2, -3. And again, if you were to graph it, make sure that lands on the graph. If you're not confident what you're doing. The coordinates of these are right here. Which type of triangle is it? So we had to plot it and look. -2, -3. 8, 2. And 4, 5. Okay. Now that looks like that might be a right triangle. It's close, so we need to check the slope. Check the slope from here. Or this is, oops. Okay, go back to the pen here. This was 4, 5. Well, I could just go 1, 2, 3, 4. 1, 2, 3. That's a +4 from one there. So remember, it's changing y. It's -3 over changing x. So that's -3/4 for that slope. Okay, now if I go from here down to here, I'm going down 1, 2, 3, 4, 5. I'm going left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which then simplifies to 1/2. So there, oh, I was testing this one and this one. I need to test this as where I was thinking the right angle was. So I was a good practice, but now I'm testing this slope. -1, 2, 3, 4, 5, 6. There. 1, 2, 3, 4, 5, 6, 7, 8 there. Okay, so if I'm going from here, it's +8. I'm going here, +6. If I'm going from that point to that point. So that slope is 3/4. Okay. Well, this one was -3/4. Okay, those are not negative reciprocals, so therefore it's not a right triangle. Okay. So now I have to look at which one's the longest. So I can use Pythagorean theorem. 1, 2, 3, 4, 5. Okay. Pythagorean theorem to get these side lengths. Okay, I mean, it looks like it's going to be an obtuse. Okay, it's not equiangular because that means it's equilateral. It's not right. We just saw that slopes are not negative reciprocals. It looks like this looks like it's obtuse, but we need to go ahead and confirm it. So this length 100 plus 25, 10 squared plus 5 squared, 125. So I have a square root of 125 right there. This one is 64 and 36. So that's a 6, 8, 10 Pythagorean triple right there. And here we have a 3, 4, 5 Pythagorean triple. There's our Pythagorean triples coming in again. So now we go ahead and this is the longest because square root of 125 is longer than 10. So squared out 125. Therefore, how does that compare to the other two? 10 squared plus 5 squared. Oh, hold up. I did something wrong here. 4/3. Oh, dang it. This is not 3/4, it's 4/3. Change in y. 8 over change in x. 6. 4/3. 4/3 is the negative reciprocal of negative 3/4, so it is a right angle. I knew it looked close to that, which then when we did this, notice when we did 10 squared plus 5 squared, I get 125 equals 125. That's why I knew, therefore, it was a right angle. If those are equal, it's a right angle. If this was greater than that combination, then it's obtuse. The longest side always goes right here. And if this longest side was less than this, whatever this a squared plus b squared, then it's acute. Those are the rules. Again, you have them on your DCAS sheet. Okay, I got lazy and tried doing it too quick. It should have been 8 over 6 instead of 6 over 8. Find the perimeter. Okay, so again, I have a vertical. I just count that 1, 2, 3, 4, 5, 6. So I have 6 plus. Now I need to find these lengths. 1, 2, 3. Draw a triangle. 1, 2, 3. 1, 2, 3. Okay, well, we know that therefore is a 45, 45, 90, also called the isosceles right triangle. Remember that, because they use the word isosceles right triangle. I know to draw that right there and put those on there, and then that's this hypotenuse is square root 2 times longer, so plus 3 root 2. And now I do it again here. 1, 2, 3. 1, 2, 3. Oh, so that's another 3 root 2. There's another 45, 45, 90. And 3 root 2 plus 3 root 2 is 6 root 2. So I have 6 plus 6 root 2 is the exact answer. Notice they wanted the exact answer there instead of round. That's why you don't see any decimals there. Okay, next. Let's make sure it didn't skip. Next. The verse of the triangle are this. Find the coordinates of S, the midpoint of AB. So the midpoint of AB, that's just midpoint formula. -3 plus 3 is 0, divided by 2 is 0. 2 plus 4 is 6, divided by 2 is 3. So there's S. T, the midpoint of BC. So now we do the midpoint between B and C. 3 plus 1 is 4, divided by 2 is 2. And -6 plus 4 is -2, divided by 2 is -1. Okay. Verify that ST, the length of ST, is half the length of AC and that ST is parallel. So now we're having to find slope and distance. So how far is it from S to T? Remember, I can change the colors. I can just go 0 to 2 is 2, so I square it, and 3 to -1 on the number line is 4. Square it, so it's 16 plus 4 is 20. So that length of ST is square root of 20. And they want to say it's half the length of ST. So ST, sorry, half the length of AC. So how far from A to C? Well, how far is it from 1 to -3? That's 4. Square it. How far is it from 2 to -6? That's 8. Square it. We have 64 plus 16 is 80. So AC is the square root of 80. Okay. So is ST half of AC? You might say, oh no, it takes 4 times. But don't forget, it's the square root of 4 times the square root of 20. That gives me the square root of 80. And what is the square root of 4? 2. So 2 times ST equals AC, and that's exactly what it says, or half of. I could have also just simplified this as well. I could have done that's 2 root 5. Like I said, that's 16 times 5, which is 4 root 5. And then I get root 5's cancel out and get the 1/2 right there. 2 over 4 reduces to 1/2. Okay, so now I've shown that. Okay, so I'm going to erase that so I can now do the slope. ST. What's the slope? Change in y over change in x. Change in y. 3 minus -1 over change in x, 0 minus 2. So I get 4 over -2, which is a -2 slope. So I better get a -2 slope for AC. So now I do the same steps for AC. AC. Slope of AC. Change in y, 2 minus -6 over change in x, -3 minus 1. Gives me 8 over -4, which reduces down to, or simplifies down to -2. Now I've shown that they're parallel. This is what you must do. That's algebra 1. Both those are algebra 1. Okay, find the equation of the line of symmetry of the isosceles triangle shown. So which two lengths are the same? 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. So those are the same right there. Okay. Line of symmetry is going to go from the vertex to the midpoint of the opposite side if you're going to split it in half. So what is that midpoint? Okay. What's the midpoint? Midpoint formula. 2 plus 8 is 10, divided by 2 is 5. 3 plus 1 is 4, divided by 2 is 2. So this is 5, 2. 1, 2, 3, 4, 5, 1, 2. That's it right there. 5, 2. So now I need the equation of that line right there. All these algebra skills. Okay, so I have a point. I have 2 points. I can pick one of those for the point slope formula, but now I need the slope. So what is that slope? Slope again is change in y over change in x. Change in y, 2 minus -1 over 5 minus 6. 3 over -1 or -3 is my slope. So I use that. Y minus, we'll just take 6, we'll take 5, 2. So y minus 2 equals -3 times x minus 5. That's an equation of a line in point slope form, but let's say it was multi-choice and they had it in slope-intercept, so I'd have to solve for y. So very simply, distributive property, I get -3x, and I have plus 15, and a plus 2 more is plus 17. And there it is in slope-intercept form. All right, graph the rectangle and find its area. -6, 1, 1, 2, 3, 4, 5, 6, 1. -6, 7. -6, -7, I meant. 10, 9, 8, 7, yep. 4, -7. 4, -7, and 4, 1. Oops, that's 3, 1, 4, 1. Okay, so that should be nice and easy. I can't believe they give you that one that easy. Find that area, it's just base times the height. So how far from -7 there to +4 there? That's 11. How far is it from 1 down to -7? That's 8. What's 11 times 8? 88. And then units squared, whatever it is. Base times the height. Use slope and or distance formula to determine the most precise name for the figure. So I have a quadrilateral again. Notice rectangle, rhombus, or square. All those are what? What do they all fall underneath? We've already talked about this. Parallelogram. I mean, this is a parallelogram because that's why they have 3 of those there. And they want you to figure out which parallelogram is it, a rhombus, rectangle, or square like we had done before. -6, -7. -4, -2. 2, -1. And 0, -4. Hmm, that does not, that only looks like a quadrilateral right there. That doesn't look like a rhombus, rectangle, or square. Okay, because this is not parallel one, and then 1, 2, 3, 4, 5, 6. So that slope is 1/6 versus this is 2. I mean, let's see, 1, 2, 3, 1, 2, 3, 4, 5, 6. 3, 6. That's 1/2, and that's 1/6. They're not parallel. Opposites aren't parallel, which all these opposites are parallel. Did I plot everything right? -4, 1, 2, 3, 4. -4, -2, yes. 2, -1, yes. 0, -4, yes. And -6, -7, yes. So this is quadrilateral only. Okay. All right, rhombus. They're telling us rhombus. Remember, that's a parallelogram with all four sides congruent. Has those vertices. What's the perimeter of the rhombus? Okay, so we just find the distance. So from S to T we need, from T to A we need, from A to R we need, and from R to T we need. Those distances. Remember this, when there's nothing above the S and the T, that means the distance or the length from S to T. Okay, you can sit there and graph it. I'm going to show you just using arrows here. From S to T, how far from -1 to 2? That's 3, so I squared. How far from 2 to 3? That's 1, I squared. And then it's the square root of that. 9 plus 1 is 10, so that's the square root of 10. Okay, how far from T to A? So now we're looking at T to A. 2 to 3 is 1 squared, and how far from 3 to 0? 3. So that's also the square root of 10. Okay. Oh, it's a rhombus. Oh my goodness. I just wasted my time. Remember, I just got done saying a rhombus is a parallelogram with all four sides congruent. So once I find the length of one of them, they're all the same. I just multiply by 4, so it's 4 root 10. Okay, now, it wasn't necessarily bad because I did another and found out it's square root of 10. That means I did it right because I better get all four sides congruent. So if I get 2 of them congruent, that means I've been doing it right. That's I guess you can call it a check. All right, the endpoints of one side of a regular pentagon are this. What's the perimeter of the pentagon? Um, so remember, since it's regular, we know what that means: equilateral and equiangular. So that means once I find the side of one side, which is right there, find that length, that is multiplied by 5, since it's a pentagon. So how far from -1 to 2? That's 3 squared. How far from 4 to 3? That's 1 squared. 9 plus 1 is 10, square root of 10, and I multiply that by 5, I get 5 root 10. Coordinates of the vertices A and B of triangle ABC are this. If the area of triangle ABC is 24 square units, what could be the coordinates of point C? So we know that area equals 1/2 base times the height. Okay, so 3, 4 to 312, that's a vertical line. 3, 4, 1, 2, 3, 4 to 312 right there. Okay, so from 4 to 12 is a total of 8. That distance is 8. Okay, well now that's my height. For example, if I go right angle is 8, and it's 1/2 of the height, 8 times the base. That has to equal 24. So half of 8 is 4 times where the base is, has to equal 24. So therefore the base has to equal 6. So therefore I need a length of 6. So I could go out 6 in either direction. 1, 2, 3, 4, 5, 6. What's that point? -3, 1, 2, 3, 4, -3, 4. We see that there? We don't see that on there. I could go out 6 this way. 1, 2, 3, 4, 5, 6. And that would be 9, 4. Okay, I don't see that one. What did I do? 6? 1, 2, 3, 4, 5, 6. Yeah. Okay. I could also go out this way up here and here. Okay. Let's plot. So I don't see those directly right there. Let's plot these and calculate. So 3, 6. 1, 2, 3. 1, 2, 3. No, that can't be it at all. It can't be on 3, 6. 8, -3. 8, 1, 4, 5, 6, 7, 8, negative 3. We have this right there. Probably not negative 3, 8. 8. Okay. Negative 3, 8, that's a possibility right there. Okay, 6, 3. That's not going to be it right there, 6, 3. So negative 3, 8 is looking good. Okay, so we have a vertical right there, and if I take this looks like isosceles. 1, 2, 3, 4, 5, 6, and there's my height of 6. I have a right angle. Okay, remember the height goes from the vertex down to the perpendicular of the base. There's the perpendicular base. So I have an 8 there and a 6 there. It's 48. Half 48 is 24, which is what we're looking for. So there's my answer right there. So this one you'd want to use the graph to figure it out. Plot them. Quadrilateral ABCD is graphed on a set of axes below. Which quadrilateral best classifies ABCD? Well, let's see. That looks like a rhombus. Okay, obviously it's not a square, it's not a right angle, so those aren't right angles. We gotta check these lengths here. 1, 2, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2. 1, 2, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2. Yep. All congruent. So therefore it's a rhombus. Okay. Now, you can say, well, that's also a trapezoid, at least one pair of parallel sides. Well, here's the problem. There's some books, and I don't know if DCAS does as well, that they only accept a trapezoid to be only one pair of parallel sides, not at least one pair. So if it came down to it, you're looking at this, and you see the rhombus, all four sides congruent, you're going rhombus, even though by our definition it's also a trapezoid. Okay, the diagonals of a rhombus team intersect at 2, 1. If the equation of the line that contains diagonal TA is that, what's the equation of the line that contains diagonal EM? Remember, the diagonals are perpendicular. So what is the perpendicular slope of negative 1? Perpendicular slope would be positive 1. Okay, and it goes through that point. So we have y minus 1 equals 1 times x minus 2. That would be the point slope answer. Okay, but if there's no choice, they might have it as slope intercept or write it or have a blank box. Sometimes they have this and say y equals. Well, now you have to put it in slope intercept form if you see that. So now we distribute that. I'd have x minus 2 plus the 1 gives me x minus 1. Okay. The coordinates of two vertices of a square are 2, 1 and 4, 4. Okay, that's going to create a square. Determine the slope of side BC. So if I have AB, BC is next, so it has to be perpendicular. Remember, right angles mean perpendicular, so we want the negative reciprocal. So we find this slope, change in y, 4 minus 1, over change in x, 4 minus 2, so I get 3 halves. So what is the perpendicular slope of 3 halves? Negative 2/3. There's my answer. Okay. All right, use the slope or distance formula. I think we already did this one, so we're not going to do this one again. Must have copied in there. A circle whose center is the origin and passes through the point negative 5, 12. Well, if that's the origin, I'm going left 5 and up 12, left 5 and up 12. I should automatically recognize that as a Pythagorean triple. 5, 12, 13 Pythagorean triple. Look how quick you pop that out. That's my radius. What point also lies on the circle? Okay. It needs to have a length of 13. So which one is 13 units from the origin? Okay. So if I have x squared plus y squared equals 169. Okay. So if I square this, for example, it's 121. I square that, that's 4 times 12 is 48. What's 121 plus 48? Oh, that's 169 right there. So this point is on it. Okay. Or if I have an equation, they give me the x and y, I just plug it into the x and y. If it comes out to be true, as this does, then that point is on the circle. Okay. So I went ahead and wrote the equation of circle. It's at the origin. That's why it's x squared plus y squared. It's found the radius, 5, 12, 13, Pythagorean triple. So then 13 squared, because remember on the right side is r squared. 13 squared is 169. And then I could just plug this in and see that'd be 100 plus 9 is only 109. This would be 144 plus 169, way too high. This would be 64 plus 25 times 21, way too high. Times 21, way too high. Okay. Find the coordinates of the center and the radius of the circle with diameter. I told you we've already done this problem in our homework. So I have to get the midpoint. This is the endpoints of diameter. So I need the midpoint. 6 plus negative 2 is 4. Divided by 2 is 2. And 7 plus 1 is 8. Divided by 2. So what did that give me? 2 comma 4. There's my center. Okay, so 2 comma 4 wipes out those right there down to these two. And the radius. So how far from 2, 4 to either one of these points? I'll go to that one. How far is from 2 to negative 2 on the number line? 4, so I square it. How far is it from 4 to 1 on the number line? 3, so I square it. Oh, 3, 4, 5, Pythagorean triple. There it is, 3, 4, 5, Pythagorean triple. Okay, see how these Pythagorean triples are coming into play, why I tell you to memorize them. Saves yourself a lot of time. Find the center of a circle. If one chord has endpoints this, and there, has endpoints 19, negative 20, and 19, negative 6. Okay. Hint, use the picture below. How do you find the center? Okay. So we have this. The chords are perpendicular. So if I do the equation, notice it's going to be a perpendicular bisector. So I'm going to take that, find the midpoint. Okay. Find this slope here, and then I do the negative reciprocal for the perpendicular slope. I then do the same thing with here. Find this midpoint, find that slope, the negative reciprocal, and then I have to find where those two lines intersect. Okay, so this is quite a bit of work, but we'll go ahead and do it. Midpoint. 7 plus 11 is 18 divided by 2 is 9. Negative 12 plus negative 16 is negative 18 divided by 2 is negative 9. Okay, what is this slope? Okay, so the parallel slope, which is the actual slope itself, change in y, negative 6 minus a negative 12 is plus 12 is 6. 11 minus 7 is 4. So that's 3 halves. So I need the perpendicular slope of that, which is negative 2/3. So I'm going to use that with that line. I do the same thing again here. 19 plus 19 is 0. 38 divided by 2 is 19 of it. Negative 20 plus negative 6 is negative 26 divided by 2 is negative 13. What's the slope? 19, negative 6. 19, negative 6, and 19, negative 20. That's a vertical. That's no slope or undefined, so the perpendicular of that is a horizontal line, and a horizontal line has a slope of 0. So the perpendicular slope here is 0. Okay? So that means it's a horizontal because I'm going to do y minus a minus 13 is plus 13 equals m 0 times x minus 19. Well, that wipes this whole side out. So y equals negative 13. Okay, that has to be set. So the center has to be at y equals negative 13. Okay, well now when I go ahead and write my equation for this top one using this information, I have y plus 9, put in point slope form, equals negative 2/3 x minus 9. Okay, well remember we already know what y is. So it's something comma negative 13. So I can plug that negative 13 right into there. What's negative 13 plus 9? Negative 4. Now I can just solve this for x, and I get my answer. So I multiply it by the reciprocal, which is negative 3/2. Whatever you do to one side, you do the other side, negative 3/2. So that's going to cancel forward. 1 over 2 is 2 times 3 is 6. Negative times negative is a positive. 6 equals x minus 9. Now I can take off the parentheses because don't forget those canceled out. Take out the parentheses and now just add the 9 across. X equals 15. So the answer is 15 comma negative 13 is the center. Okay, so there's several steps involved. Okay, right there. A circle is centered that and a radius of 4. So if I go ahead and make it, x minus 1 quantity squared plus y plus 2 quantity squared equals 4 squared, which is 16. Does the point 3.4, 1.2 lie on the circle? In other words, I plug in 3.4 there and a 1.2 there. If that comes out to be 16, then it lies on the circle. If it doesn't lie on the circle. So I have 3.4 minus 1 is 2.4 squared plus negative 2 plus 2. I'm sorry, 1.2 is what I'm plugging in. 1.2 plus 2 is 3.2 squared equals 16. Well, 2.4 is 24 times 24 is 576. So it's 5.76. 3.2 or 32 times 32. Let's see, it's 4, 6, 24, 10, 1024. Okay, so move it over 2 places, 10.24. Does that add to 16? Yes, it does. So that point is on the circle. Okay, now you get to use a calculator on that. I did it in my head, but you can plug that in a calculator to get those. Okay, and check it. Find the circumference of the circle. So I gotta remember circumference equals 2 pi r. The nearest tenth with the points negative 10, and negative 3 as the endpoints of the diameter. So it's either circumference equals 2 pi r or pi d. Well, we have the diameter right now. Okay, so we can just find this distance. How far from negative 3 to negative 10? 7, so I square it. How far from 8 to negative 10? That's 18, and I square that. 49 plus 18 squared is 324. Those of you who memorize your squares, I've told you to for extra credit, 11, 325. Add that together, and that's 364, 373. Okay. Square root is 373. Okay. And that's my diameter, so it goes in there. Now it's a calculator problem because it doesn't tell you to use 3.14. You use pi in the calculator times the square root of 373 and then round to the nearest tenth. By the way, if you don't do all that right and you don't round to the nearest tenth on the DCAS, you get no points for it. You have to know how to round correctly. You better know how to do it, or you could do problems right and get no credit. The second side of a triangle is 2 more than the first side. Okay, so if the first side is x, the second side is 2 more. That's x plus 2. And the third side is 3 less than the first side, which then is, that's first, second, so 3 less than the first, x minus 3. Which expression represents the perimeter? I just add those together. 3x minus 1. Perimeter. Okay, so algebra skills, changing words into algebraic expressions, perimeter, knowing that, and adding. If the perimeter of a square is about 28 inches, which of the following could be the measurement of one of the sides? Remember, a square has all 4 sides the same, so the perimeter is 4s. That equals 28. Okay, so s is 7 if it was exactly 28. But notice it says about 28, so it's got to be really close to 7. Okay, what's the only one really close to 7? 6.8. Okay, that's going to be your answer. Use any problem-solving strategy to solve the following problem. A square has a perimeter of this, or a perimeter is 4s. It's saying equals this. What's the length of each side? So I just divide by 4. This is now algebra skills. Algebra 1. Divide each term by 4, and I get 4x squared plus 1. That's each side. So if I multiply that by 4, I would get the 16x to the 16x to the 4th. I put squared. So it's x to the 4th. 4x to the 4th plus 1. Sorry about that. Okay, find the perimeter of the figure below. Write your answer in simplest radical form. Oh, they'll say they don't want 4x, they want it as answers, as numbers. So you should remember this in a isosceles right triangle, which means a 45, 45, 90. Okay, which means they give us the hypotenuse, 12. You can either set that to a root 2 and solve it like this, or divide, which means divide by root 2 on both sides, rationalize the denominator. I get 12 root 2 over 2, and then simplify it down to 6 root 2. There's it, doing algebraically, but remember I told you the shortcut, you just take half the number, it gives me 6, and add on the root 2, and there you see that exact answer right there. That's the shortcut. Okay. In the accompanying diagram, segment CD is an altitude. I've shown that with the right angle there. Altitude, remember another word for altitude is height. You should know that. You've been quizzing each other in your DCAS, those who've been taking it seriously. If CD is 8, measuring angle A is 45, and measuring angle B is 30, that's all written in there. Find the perimeter of triangle ABC. You want the perimeter of the whole thing. Well, I know if that's 30, the hypotenuse is double that, so that's 16. This is the 60-degree side, which means it's root 3 times longer than the 30-degree side, so that makes it 8 root 3. This is a 45, 45, 90, so that makes this 8, and the hypotenuse is root 2 times longer. Now I have all I need. I have all the sides, I can add them up. I combine like terms, 24 plus, and I can't put the root through and root 3 together because they have to be the exact same radical. So there is the exact answer. Notice it says simplest radical form. This is the answer, no decimals. All right, we made it through finally, an hour. All right.